All right, we're on the second video for functions, and we're still talking about the vertical line test. We are going to also find domain and range. So let's take a look at the graph in pink, the pink graph and talk about that. So notice on the pink graph, I have these two curves, right? This is a hyperbola basically, and there's two parts to it. But if I draw a vertical line on either part, you can see that it's going to intersect more than one time. So if I draw my lines through these graphs like this, then we get two intersections, which means that, and really if you think about both sides, there's four intersections, but only a vertical line can only intersect it two times in this case, but it is more than once. One time means it's a function. More than one means it is not a function. So not a function. And then we have to write our domain and range. So for our domain, we have to name both parts of this, right? We have to say, okay, so this thing is not only going to extend up and down, right? It's going to get taller and you know, up. It's going to go in the up direction, the down direction, but it's also going to get wider. So it's going to continue on the negative side of the x-axis and the same on the positive side of the x-axis. So here's how I have to name this one. Negative infinity, and we go to -2. Okay, so I'm going to say -2, and this one is a union. Then it picks up again at +2, and then to infinity. Just kind of look left to right. What's happening over here on the left, what's happening over here on the right, because we're just talking about the x-coordinates and that's it. And then for the range, this thing just continues on and on and on in the positive and negative direction. So on this, it's negative infinity to positive infinity. Now don't forget while you're working through the videos to pause and think about these things and try to answer before you watch what I have to say. All right, so let's look at the next graph. This graph is going to continue on in the same way. Notice that it's going from here to here. It's going back and forth from -1 to +1, -1, +1. And so we're going to look at that when we're talking about domain. If I draw vertical lines through this part, all right, a vertical line, you can see intersects several times, and it's going to continue on in the same way. And so we can tell right away that this is not a function because I have repeating x-coordinates, not a function. Now let's talk about that domain. So I gave you a little hint on that already. My domain goes from -1 to +1, right? It's just curving back and forth, and it continues on and on and on in the negative and positive direction for the y, but for the x's, it just simply goes from -1 back to 1, then back to -1, then back to 1. All right, so range in this case is going to just be negative infinity to positive infinity because it continues on up and down, right, toward the positives and the negatives. Okay. So, all right, next we're looking at whether something is a function or not based on the equation. And so you might have to just play with this a little bit to figure it out, but I will tell you this. If it is not a vertical line and it's a linear equation, then yes, it is a function. And I have that written up here, right? All linear equations are functions except those whose graph is a vertical line. And a vertical line is x equals a number. And so that's the equation of a vertical line, right? X equals 5, x equals -2, something like that. So that means that y equals x minus 1 is a function. It is a function. And because, I'm going to say because on this one, because for each input, there is, whoops, not they, there is only one output. So it would pass the vertical line test. And I think about this. Okay, so if I put 0 in for x, y is negative 1. If I put 5 in for x, y is 4. If I put negative 8 in for x, y is negative 9. So no matter what I put in for x, I'm going to get a value of y that's different than any, every time I put in the same number, I would get the same answer. So there's no repeating on the x, and I'm going to get a different number each time. Okay, on this next one, this is a parabola. So I talked to you about parabolas on the previous section, right? This parabola looks like this. So just knowing that could be helpful, y equals x squared. If you're not sure, you could just kind of set up a chart and look at that, right? If I put in some, -1, +1, and so on, and just check, does it pass the vertical line test? So if nothing else, you could always put this on a graph and look at it that way if you're not sure, but this one is a function. Okay, so we're done with that. Okay, so next we're going to use function notation for some evaluating. And when we evaluate, that simply means that we're going to just substitute in the number and calculate. So with function notation, this is evaluating a function. It's not solving an equation, it's evaluating, so we simply substitute into the proper function, okay? So notice we have an f of x function, we have a g of x function, and we have an h of x function. Now, this is called function notation. What this allows is that we can name different equations with a different function name, and then we can distinguish between those functions based on that. And notice this function notation, this is red, f of x, g of x, and h of x. So that's how we talk about functions. Hopefully you've learned about functions in the past, because this should be a little bit of review. If I substitute in my f function, then I'm going to say 3 times 4 plus 3. So that's 12 plus 3, which is 15. Now, I am not solving an equation. Make a note to yourself. We are not solving an equation here. We're simply substituting and evaluating. All right, so on the h function, I'm going to substitute a 0. So this is 5 times 0 squared minus 7, which is 5 times 0, and 0 minus 7. Now I'm writing out several steps. If you were working something like this on a test or something, I would want to see those steps. So just keep that in mind. You should always be showing your steps as you're working through any of the things that we do in this class. Okay, so the g function, be careful that you're selecting the function that you need. On the g function, I'm going to substitute a -1. Now you guys, you have to be careful here, because a lot of times students make mistakes because of signs when they're substituting a negative number. So this will be 4 times 1, because -1 squared is 1. -6 times -1 is a +6. Right, so this is 4 plus 6 plus 3, and that's going to give me 13. Now, the other thing that I hadn't mentioned is that we actually just made ordered pairs because we took an x coordinate, substituted in, and we found f of x. Well, f of x takes the place of y. So for this first one, we had an ordered pair of 4, 15. On the second one, the ordered pair is 0, negative 7. And on the third one, my ordered pair is negative 1, 13. All right, so we have a bunch of ordered pairs. You can use functions whenever you're graphing, and we will be doing that coming up. Okay, so this is the same type of question we're just evaluating. So we're going to take each function and substitute in. So in my g function, we substitute a 2. So 4 times 2 squared minus 6 times 2 plus 3, right? So this is going to be 4 times 4 minus 12 plus 3. And so that ends up being 16 minus 12 is 4. 4 plus 3 is 7. So that's what we end up when we evaluate there. Let's evaluate the the h function. So h of negative 2 is 5 times negative 2 squared minus 7, right? So 5 times 4 minus 7 is going to be 13. Okay, and then the f function. The f function is a pretty simple one, f of negative 3. So 3 times negative 3 plus 3, negative 9 plus 3. And then that would be negative 6. All right, let me see how much more I have to go on this. 3 minutes, I'm not sure, because I like to try to keep these under 15. So I'm going to stop this video and then we'll finish up just this little bit on a third video.